Hello, third graders. Okay, so today and tomorrow we're going to spend 2 more days on area and perimeter, and then we'll be finished, sadly, because I think area and perimeter is lots of fun, because we can use lots of different tools to practice. But today and tomorrow we're going to be working on how to compare area and perimeter, particularly if noticing how shapes could have the same area but different perimeter, or the same perimeter and different area. So we're going to see how those two concepts are related, okay? One thing that you have to keep in mind is the difference of how you find the measurement and what you're looking for, okay? So have you ever heard your mom or dad call a small rug called an area rug? It covers a small area, okay? So the area, if you kind of think of it as the rug, is what it covers, okay? Things that cover. And then in the word perimeter, do you see that word rim? The rim. Do you know what a rim is? Like if you think of the rim of your cereal bowl, it's the edge of your cereal bowl. It's not the whole cereal bowl. It's not how much the cereal bowl can hold. It's the edge, or the edge of your cereal bowl. So perimeter is around the edge of a shape. So that's more like a fence, okay? So if you kind of keep those two things in mind, then area is like a rug, covering how much space it covers, and perimeter is the rim around, or like a fence around your yard, okay? All right, so let's just do a quick review. Here come my Legos. I love Legos. I've been playing quite a bit with Legos lately. Okay, I'm not sure if you can see them as well because it's a little bit dark, but I have 3 different things built on my plate, and they all have the same area. They do. They all have the same area. They all take up the same amount of space. They all have the same number of square studs, if I was going to count my studs, right? Okay, so let's take a look. Let me actually erase this underneath so that you don't get confused. Sorry. Okay. Let's take a look at this very first one over here. This one has 1, 2, 3, 4, 5 in a row, and it has 1, 2, 3, 4 rows. So it's length times width. If I was going to find the area, the length times the width, it would be 5 times 4, or I have an area of 20 square. Oops, you can't even see. Sorry. 20. I'm writing all this. Uh-oh. Going the wrong way. 20 square studs. I am not fancy videographer. Square studs. I'll just say area of square studs, okay? All right, so my area of this shape is 20. If I take a look at this shape, ready? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 rows of 10. So 2 times 10 would be my length times my width is equal to 20. So my area is 20 square studs, okay? Because 2 times 10 is 20. This is 20 square studs over here, and this one's 20 square studs. Can you guess what this one is if I told you they're all the same area? You're absolutely right. It's 20 square studs. It's a 1 row of 20. Okay, so all 3 shapes have an area of 20, but they all have very different perimeter. If I was going to build a fence around this shape, I would have to add 5 plus 4 plus 5 plus 4. So let's go over here. You ready? For my perimeter, so that's my area. For my perimeter is going to be 5 plus 4 plus 5 plus 4. Now I would take my 2 5s and say that's 10. My 2 4s is 8. So 10 plus 8. So my perimeter is equal to 18. Okay? So 18 studs, right? 18 studs. 18 studs would be that one. All right, if I went over to this one, this side would be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This side would be 2. This side would be 10, and this side would be 2. So the perimeter of this shape, perimeter, would be 10 plus 2 plus 10, plus 2. Squeeze that in. Plus 2. Okay, I'd add my 2 10s together. So the perimeter would equal 20 plus my 2 2s, 4. So the perimeter is equal to 24 studs. Okay, so now look, this shape has a perimeter of 24 studs. This shape had a perimeter of 18 studs. So this one, while they're the same area, this one has a greater perimeter. What would you think about this one? Do you think it's going to be greater or less than the perimeter? Do you think the perimeter is greater or less than this last one that we just did? Well, let's find out. This is 20, right? That's 20 plus 1 plus 20 plus 1. Can we do this in our head? 20 plus 20 would be 40, plus 1 would be 2. So this one would have a perimeter of 42 studs. This one has a perimeter of 24 studs, and this one has a perimeter of 18 studs. So the areas of all these rectangles are the same, but the perimeters are vastly different, okay? So that's what we're going to be practicing with in these next 2 days. What I want you to know is that we're going to be combining lessons 11.9 and 11.10. So we're not going to spend all week on it, but we're going to combine 11.9 and 11.10, and we're going to do a few pages in each one. So I need you to make sure that you read the directions really, really carefully, because you're not going to do every single page in 11.9 or every single page in 11.10. You're going to do a few in each one. So follow the directions real carefully and make sure you get all of those questions answered, okay? All right, I want us to do a couple together. So we're going to do, if you could turn to page 675, and that's in 11.9. Okay, so turn to page 675. And again, you know what? Sometimes they put so many words and so many pictures. Let's just see if we could solve this one together, okay? It says that Toby has 12 feet of boards to put around a rectangular sandbox. How long should he make each side so that the area of the sandbox is as large as possible? Okay, so let's think about what we know. He has 12 feet of board. Is 12 feet of board, is that going to be our area or our perimeter? Think about that. 12 feet of board to put around his rectangle. So that's going to be the perimeter. We know that we need a perimeter. What do we know? We know we need a perimeter is going to equal 12 feet, because that's how much board he has, right? And we want the largest area possible. So we want the largest area. Okay, so let's see. What ways could we come up with to make a perimeter of 12? All right, well, again, I'm going to use some of my Legos, but you could use graph paper, right? Just like they do underneath. One way that I could do it is I could do the first example, sandbox number 1. I could do, ready, a sandbox in this shape. It would have 5 by 1. So this side would be 5. This side would be 5. That's 10 plus 1 would be 12. It has a perimeter of 12. Okay, so that could be sandbox number 1. Another option I could do is to do a 2 by 4. There's sandbox number 2. Boom. 4 by 2. Ready? 1, 2, 3, 4. So 4 plus 4 is 8, right? 4 on this side, 4 on this side. That would be 8. 2 on to this side, 2 on this side. That would be 2 plus 2 is 4. 8 plus 4 is 12. Same perimeter. Can you tell that they have different area though? All right, and then my last way, another way I could make a perimeter of 12 is to do a 3 by 3 model. Okay, so here's a 3 by 3 model. Hold on, that's taking me a bit. Okay, a 3 by 3 model. Same perimeter. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So all of these rectangles, all of these shapes have a perimeter of 12 feet. But we want to know which one has the largest area, because that's what the question says. It asks, how long should he make each side so that the area of the sandbox is as large as possible? Could you take a guess? If you were going to sit in one of these sandboxes with a friend, which one would you want to sit in? Okay, let's see. You ready? This one has an area of 5 times 1. This one has an area of 5. In this picture, 5 square studs. In the picture that they drew in the book, it would be 5 square feet, right? I'm sorry. Yes, 5 square feet. Okay. This one would have an area of 4 times 2, an area of 8. 8 square feet in our book with the Legos, 8 square studs. This one would have an area of 3 times 3. 3 times 3 is 9. 9 square studs in our Legos, but in our book, 9 square feet. So which one has the largest area? Yes, our last one. A 3 by 3 has the largest area. But do you notice how all of them have the same perimeter, but they have different areas, okay? So in lesson 10.9, you're going to be practicing same perimeters, different areas, okay? And then in lesson 10.10, all you're doing is switching it. You're doing same areas, different perimeters, okay? So this time, could you turn to page 691? Oh, sorry, 681. 681, okay? That's in 11.10. Okay, ready? Let's listen to this problem. Gotta get it closer to me so I can see it. Macy is making a rectangular pen to hold her rabbits. The area of her pen should be 16 square meters with side lengths that are whole numbers. And that means that there are no fractions, they're whole numbers. What is the least amount of fencing she needs? Okay, so let's think about what we know and what we're looking for. It says she wants a pen, the area of the pen should be 16 square feet. So we know that the area has to equal 16 square feet, or in our Lego example, it's going to be 16 square studs, right? And we want to have the least amount of fencing. So what does that tell us? We want to have the smallest perimeter, okay? All right, so let's scooch that up. All right, so you ready? Let's think of ways that we could make a shape with an area of 16, okay? Well, one way to make an area of 16 would be to do a row of 16, right? Boom. Boom. It says an area of 16. 16 times 1, area 16. Another way to do it would be to go like this. Boom. Boom. 1, 2, 3, 4, 5, 6, 7, 8. Right? Times 2. 1, 2, 3, 4, 5, 6, 7, 8 times 2. 16. Area of 16. Can you already tell which one would need less fencing to go around it? I bet you can. Okay. And another way we can make an area of 16, we know 16, oh, that's an easy fact because that's a double fact, isn't it? So that pops into our head. All right, let's come over here. Boom. Boom. Okay, ready? Let's see if it has an area of 16. 1, 2, 3, 4 by 1, 2, 3, 4. 4 by 4. Okay? So as I'm trying to think of all the ways I could get an area of 16, I'm thinking of the different combinations I know that when they're multiplied, the factors equal 16. I know 1 times 16 is 16. I know 2 times 8 is 16. And I know 4 times 4 is 16. So I used those dimensions to make these shapes. Okay? But that doesn't answer my question. Let's go back to the question. It says, which shape should she use, or what should her sides be? Record the rectangles on the grid and then write the multiplication equation for each area shown by the rectangle and find the perimeter of each rectangle. But they're asking us, sorry, let's go back to the question. It says, what is the least amount of fencing? Okay, fencing goes around the rim, perimeter, okay? So the perimeter of this shape would be 16 plus 16, that's 32, plus this one, 33, plus this one, 34. So the perimeter of this one would be 34. Oops, you can't see, sorry. 34, here, I'll write it up here. Perimeter is equal to 34 for this white one. 34, they were working on meters in our book, meters, okay? This yellow one would be 8 plus 8, that's 16, right? Plus 2 plus 2, so 2 plus 2 is 4. 8 plus 8 is 16. Oh, I'm blocking it. 8 plus 8 is 16. 2 plus 2 is 4. So 16 plus 4 is 20. So this yellow one has a perimeter of 20 meters. Okay, so if I had to go buy fencing for this white one, I'd need 34 meters to go all the way around. If I wanted fencing for this yellow one, I'd only need 20 meters. Can you guess if this is more or less? Ready? I'd need 4 plus 4 plus 4 plus 4. Well, because I'm so good at multiplication, 4 times 4 is 16. I'd only need 16 meters to go around this pen, right? So the answer would be this shape, because this shape has an area of 16 square feet and a perimeter of 16 square feet. That's kind of coincidental, isn't it? But because it's a square, it has the same area as it does perimeter. But the point is, if we can make all three have the same area, we can figure out that this one has the lowest perimeter. Okay, so you're going to be practicing with shapes that either have the same area and you have to determine the perimeter, or the same perimeter and you have to determine the area. Now, always keep in mind what area and perimeter are doing. Are you building a fence around? If you're building a fence around, that would be your perim. The rim, the outer edge, the perimeter. Okay? Or are you laying down an area rug? An area rug, okay? So perimeter is like a fence and area is like a rug. And you have to know which one you're speaking about. Perimeter would be always measured in linear length. So it would be measured in inches or centimeters or meters or feet or miles. Area is always measured in square because you're multiplying the sides to find your answer. So it would be square feet or square inches or square miles, okay? So area is always a squared answer, and perimeter is always measured in a linear measurement, okay? Oops, that doesn't look like an R. A linear measurement. Okay, so as Mrs. Albert and I told you, we're trying to help do our lessons like this rather than using that Think Central Bunny. So I hope that I helped you. If you have any questions, make sure you reach out and ask. Work through just the numbers that I write down, okay? You do not have to do all of them. If you want to do all the pages, go for it. It will be great practice for your beautiful brain. But you certainly don't have to do all of them, okay? So I will give you, I think there's about 15 problems you're going to need to solve. And you'll have Monday and Tuesday to finish up all that work, okay? But it's not that hard, I promise. All right? And then maybe if you get lost in your Legos, you can build me something and send me a fun thing that I'd love to see. I loved seeing your creations from last week. Y'all created such fun, interesting designs, both on Legos and on graph paper. The other thing that I'm going to add to this is I have another challenge for you if you'd like to do it. I have a purple sheet. So I already gave you a red and a blue one. This one's purple. And these cards you can either do on graph paper or you could do with Legos. The directions are for Legos. So it says build a rectangle with a width of 7 and a perimeter of 30 studs. Okay, if I know that it has a width of 7 and it has a perimeter of 30, I have to figure out what the area is. Okay, so I'd have to really give that some thought. If I know that it has a width of 7, I know that one side is 7. Okay, so that means that the other side has to be, well, let's go to width instead of the length, sorry. Ready? If I have a rectangle and this is 7 and this is 7, right? One side's 7, so two sides would be 14. I know the whole thing is 30, so 30 minus 14 . I have 16 left and I have two sides. So what must these two sides be? Figure that out. So this side must be 8 and this side must be 8, right? Uh-oh, sorry. Didn't know you couldn't see my other 7. Okay, ready? Now can you see that? Okay, so you ready? Build a rectangle with a width of 7 and a perimeter of 30. Let's see if it has a perimeter of 30. 8 plus 8 is 16. 7 plus 7 is 14. 16 plus 14 is 30. So it has a perimeter of 30. What's the area? Well, the area would be the length times the width. 8 times 7. Do you know your backs? How many square studs is that shape? Okay, so this will have a bunch of different problems for you to solve. And some you have to build your own and find the area and the perimeter. Those are actually build your own, aren't they? Okay, so it's just the front side would be a little more challenging for you. And you could do it on graph paper or on with Legos. Okie dokes. All right, everybody, have a great day. Be sweet and kind to everybody. Keep smiling. We miss you.